Okay, Assalamualaikum and good morning, everyone. Uh, so today we continue our lesson. Don't forget to use QR code scanner, not UTM Smart. Okay, on the bottom here, okay, QR code. QR code is actually a link to a Google form. Okay, not UTM Smart. Okay, Google form. So we're still using Google Form for your attendance. Okay, don't worry, it will appear uh, at the on the other slide. Okay, the QR code for the attendance. So we continue our lesson on traceability. In by the definition, okay, basically traceability chain is an unbroken chain of comparison which all stated which all have stated uncertainties. Okay, so what is basically compared? Okay, what is basically compared? Okay, um, so the uh, comparisons involved is basically outcome of uh, measurement. Okay, outcome of a measurement. So in this regard, tools or equipment. Okay, so we take something very simple. Um, if you go to the market, okay, if you go to want to buy goods or groceries, okay, you basically some groceries, basically you have to make weight. Okay, you have to know the weight. So the weighing machine is basically a tool to measure weight. Okay, and how do you how do you how do we make sure that the outcome from the weighing machine is actually uh, weighing the exact quantity. Okay. So by the uh, regulation or law of consumers, so any um, shop or groceries or shopping mall, so all the weighing machine must be certified. Okay. And this certification have a certain due date or expiry date. Okay, meaning that the weighing machine must go through a certification process for a certain period of time. Okay, and technically, they are in Malaysia. The certification can be done by sending the weighing machine to a certified shop or enterprise that conduct the comparison, what do you call as comparison process. Okay, so basically they will have a procedure, they have their standard. Okay, and they have the other equipment, okay, which they can use as a uh, comparison. Okay, so when the outcome, okay, of the weighing machine, okay, is according to the standard, according to the then stated the process, so the certification will be issued. Okay, so so the enterprise that conduct the comparison, of course, have an equipment, okay, and then that equipment is comparable to the other standard, okay, okay, to the other standard at the higher level. Okay, so basically, like for example, in Malaysia, they have a measurement lab, okay, national measurement lab. So the measurement lab, they have their standard of weight. Okay, so they check, okay, the equipment that being used to compare with the equipment being used in the consumer level. So there are, you know, uh, caste or hierarchy. Okay, there are levels. Okay? So there are levels, and then all these can be traced through the highest level. To the highest level. For example, okay, Malaysia national standard can be traced or uh, can be related to the highest level, which is international. Okay, of course, at consumer level, we don't have the authority to request, okay, for the request to access the highest. Only the national lab, okay, can, okay, do, okay, make some arrangement to compare their equipment to the highest level. Okay, and on the top, the of the level will be the definition. Okay, for, and then most likely the the top or the highest level, okay, can be accessed only by certain people or party, not all people can access. Okay, so those are basically comparison, which all have stated uncertainty. What is uncertainty? Uncertainty is basically, uncertainty is, uh, as a whole, is basically level of confidence. Okay, the level confidence of the measurement of the outcome, which include accuracy, error, reproducibility, uh, repeatability, and and also resolution. Okay, those, okay, are included in the uncertainty being can be used in the uncertainty. There are uh, methods to determine the uncertainty of a measurement. Okay, um, some method are using the experimental method, okay, by identifying the variables, and then they use the variable and can make some measurement, and from the measurement they extract the uncertainty. Okay, uncertainty. Okay, so like I explained, the measurement result or the outcome of a measurement, okay, it can be related to the reference at highest level. Can be related, not necessarily can be compared at the spot. Okay, but they can be related. Okay, so they have the connection, like they have like uh, essence ancestry, like connection. Okay, okay, so like I explained, end user may obtain traceability to the highest level, the highest level in the in the obtain means that they can request through the national. Only the national lab can do the uh, traceability. Okay, they had only the authority. The user can only request. Okay, maybe in certain cases, for example, okay, for certain cases, in especially in for example, very high profile cases, okay, like murder, okay, they have a DNA test, okay, and then they want to okay, make sure that the DNA test is up to the international level they can submit. Okay, so DNA test is also a kind of measurement. Okay, so it, it is a form of traceability, and then there are level of uncertainty. Of course, in trial or any trial cases, they need to have a proof. Okay, a solid proof for a case, so that they can defend, or they can press charges or so on. Okay, so like I explained, traceability may involve lab. Okay, or lab means that there are lab, yeah, many level of labs. Okay, like weighing machine, like I've told you before, there are companies, okay, companies or enterprise that is certified by the government to run the certification process. So they are basically audited lah. It's like your vehicle. Okay, if your vehicle have the registration has expired for a long time, and then you want to register for a new registration, or so you need to go for inspection, and then you have to send your vehicle to Puspakom. So there is a process of traceability. Basically, traceability, you want to verify, okay, the performance of your car in terms of the safety. Okay, of course, in Malaysia, Puspakom monopolize the vehicle test. Okay, but in other country, like for example, my experience in New Zealand, the workshop they have the every workshop they have of course certified workshop. They are given the authority to provide the what is called as warranty of fitness before you can, okay, renew your car registration. Okay, so this is basically the traceability chain. Okay, as you can see, okay, there are one, okay, two, three, four, five levels. Okay, so as you can see, at each level, okay, stated condition or situation, and you see the rectangle here. The rectangle represent the amount of uncertainty. Okay, the amount of certainty. So meaning to say that for example in the end user level, so the amount of uncertainty is basically the highest, okay, as compared to the other level. Okay, meaning to say, okay, the measurement at the end user, okay, uh, the level of, okay, we take one aspect of the uncertainty, for example accuracy. Okay, the level of accuracy is basically the lowest. Okay, but of course, although it is the lowest, it must be at the level where it is safe, or the result can, okay, fulfill a certain requirement. Yeah, certain requirement. Okay, although the level of certainty is the now the volume of certainty is the highest. Okay, so we can say the level of confidence is the lowest, but the measurement should fulfill some, okay, fulfill the requirement, so, or fulfill the level that, okay, uh, okay, at certain for certain aspect. Okay, uh, let's take for example a thermometer that is used to measure the human body temperature. Okay, human body temperature. Okay, so we know that, okay, let's say it can that nowadays they have the temperature measurement device. Okay, the infrared one that we have to go through every time if we want to enter certain premise like the shopping mall. Okay, so those infrared thermometer. So yeah, so that is basically temperature measurement. Human body temperature measurement. Okay, so let's say in the end user we have that, okay, tools, or we have that equipment. Okay, so in the end user, okay, let's say the device is used to measure the human uh, body. So let's say we get the result 36.3 degrees Celsius. Okay, with a certain uncertainty. Okay, plus, minus. Okay, for example, 0.5. Okay, plus minus 0.5 degrees Celsius. Meaning to say, okay, the uncertainty level, okay, okay, this is the uncertainty level. Okay, the error, okay, is plus minus 0.5 degrees Celsius. So the measurement, the actual measurement is 36.35, but the measurement could be, okay, maybe 36.3 or plus 5, 3.8 degrees Celsius, okay, to 35.8 degrees Celsius. Okay, so this is the acceptable the range. Okay, the range of, okay, due to the uncertainty which set by the error. Okay, so this is the uncertainty at our level. Okay, so in the enterprise they have their industrial standard, they have their own equipment for body measurement, for example. Okay, of course the uncertainty is lower as compared to the end user. Okay, so maybe if the same device is used to measure, okay, the result will be 36.28, okay, degrees Celsius, plus minus 0.05, for example, degrees Celsius. So you can see the decimal number, the places, okay, okay, 0.05. Okay, so if you work out the range, of course, the range of the measurement will be the gap. Okay, the gap between the expected result, okay, is much lower than what we got from the end user. Okay, so this is an example of temperature measurement as compared from the end user to the enterprise. Okay, and how it is related, so the tools here, let's say tools, okay, here is used to calibrate, okay, the outcome of the tools at the end user. Okay, so the enterprise can be like what I said, like certificates that give the certification. Okay, certification. Okay, of course. Okay, there are higher level standard. Level standard is by the lab the bodies. Okay, they basically accredit the enterprise or the company, or not all enterprise. Okay, they want to use the accreditation to run business or to run uh, uh, calibration at the end for the end user. But basically they enterprise, they need the measurement, okay, the precise measurement, okay, for their processes like food processing. Some food processing, they need to know the exact temperature. They cannot have the accuracy, they cannot have the error too high. Okay, they have to, okay, minimize the error. Okay, and then there are calibration lab. Okay, calibration lab, like in Malaysia, we have the calibration like SIRIM. Okay, okay. And then and SIRIM is basically the lab, but at the national level they have the we will NILM. So NLM is basically the board, okay, that run the administration, and Syrian basically run the, the experiment. Okay. And then there are national lab also in Malaysia. Okay, and then the national primary standard and the foreign national primary standard. And then we have the BIPM. BIPM is the highest, the highest uh, standard, okay, which define the unit. They define, like for example, temperature. What is, how do they define, okay, temperature? Okay, you can look it up. Okay, what is the definition of temperature? Okay, uh, like they run an experiment at the Kelvin negative, something like that. But like other example, like weight, okay, uh, that weight, the standard based on okay, uh, a metal cylinder, okay, which made of an alloy at a certain height and a certain height and also diameter. Okay, so this definition uh, is dynamic. I mean, it will be revised from time to time. Okay, the purpose is to get the better standard. Okay, so for example, uh, like weight. If we use a metal alloy, okay, they have we have to, okay, preserve it, okay, properly, okay, so that it does not react to the environment, for example. So we have like put it into vacuum. So if we have a better definition, okay, so it will be uh, the best. But of course, the definition, okay, the definition, there are many aspects of the definition. The definition, one of it, it must be reproducible. Okay, let's say you say the weight of 1 kilogram by definition is from a cylinder with a certain height and the diameter. So the national meteorology in other country, they can replicate, they can reproduce. Okay, they can reproduce and then they can use it. Okay, for especially for the end user. Okay, for the society, they can realize for the society. Okay, they cannot give a definition that is not practical. Okay, okay, so this is basically the elaboration of traceability. Uh, it is a characteristic of calibration. Okay, calibration. Uh, Calibration. Okay, you may uh, find this word, especially in the industry. Okay, in your okay, maybe some of you had the privilege, okay, to go visit to the industry, so you could have find the word calibration. Okay, is this a basic tool in sharing traceability of the measurement? Is the calibration of measuring instrument or reference material? So I have explained the process before. And calibration is basically determines the performance of the characteristics of instrument or reference material. Okay, so it is achieved by means of a direct comparison against measurement standard or certified measurement. A calibration is issued in the most cases is sticker attached to a calibration instrument. So basically, you, okay, let's say have a, okay, tools A, okay, equipment A. We have equipment A. Okay, that equipment A is, okay, used to perform a certain measurement. Okay, let's say put a multimeter or voltmeter. So it's used to measure voltage. Okay, voltage. Okay, so we use it to perform a voltage. So how do you know that the voltage, okay, the voltage, for your tool, okay, giving a correct reading. Okay, so that's why. Okay, in a certain company, they will keep a tool. A tool B, a tool B is kept especially for calibration. None other than that. Okay, so none other than that. So tool B, okay, will be used to measure voltage. Let's say the circuit A, circuit A, okay, and then the same circuit A is used to measure by tool B, and then they look at the voltage, and then they compare, compare, okay, compare. So of course, tool A will be used extensively. Will be used day in day out every day. Okay, then you can expect that the performance will go down, okay, at a certain time. So due to many reasons. Okay, for example, tool A is used in a very hot condition. Okay, the measurement have to be done under the sun, for example. So you could expect, okay, that the performance will go down. That's why the calibration have to be done periodically. So at repetitive time, okay, and then it must be kept, okay, by or must be done regularly. Okay, so and then the tool B, okay, this kept for calibration, and sometimes tool B will be sent sent to the next level, lab or national lab. Okay, so to uh, verify the performance, okay, and then to basically to get the certification. So that's the process. Okay, that's basically the process. Okay, so uh, the three main reason for having an instrument calibrated. Remove. The three main reasons to having an instrument calibrated, okay, to ensure the reading instrument are consistent, okay, to determine the accuracy and then to establish the reliability of the instrument. Okay, reliability, okay, especially like for example in the health or in the hospital, it is important to have equipment that can measure, uh, for example, blood pressure, okay, properly, that can measure heart ECG heart signals properly. Okay, so here in Malaysia we have National Metrology Institute, uh, basically designated by nation to develop and maintain national measurement standard for one or more quantities. Okay, measurement standard, it can be it can be a lot of anything. It can be anything measurement standard. Okay, can be anything encompassing our the life. Okay, it can be in the industry, it can be in health, it can be in the non-industrial, okay, like in the food industry, for example, even in education. Okay, but no, education is too education if it involve the tools, yeah, but human. But if if not involved, okay, there are other means to have a standard. Okay, uh, so some countries centralize the metrology. Okay, uh, the organization. Some country decentralize they split the organization into other institute. Okay, but all have to report to the National Metrology Institute. Okay, uh, So the whole economy on the quality of our everyday life depend on the reliability of measurement, okay, and tests which are trusted and accepted internationally do not form a barrier to trade. Okay, especially okay if you want to okay do trading, okay, uh, that we must have uh, agreed to use the same standard or measurement. Okay, so the word is interchangeability. Okay, interchangeability. For example, okay, if you have a machine, okay, certain machine, okay, okay, the dimension, okay, or the unit they use is in Malaysia. In Malaysia, we use international standard or metric system. So we need to okay, obtain the same equipment or parts, okay, that employ the same standard. If we did not use, like for example, even in their uh, manual, okay, in their manual or manual means that the equipment manual, they use a different standard, so it will be difficult, okay, especially to use the parts, okay, or to integrate with our existing system, okay. So if we cannot avoid, we have to go through the painstaking process, okay, converting all the unit, okay, inside the standard before we can deploy. But of course, it does not come. It does not come with free error or no risk. So there will be risk involved. Even a slight mistake, okay, it will the consequences will have it can cause a big consequences, okay, or loss. So the worst case is human life loss, okay. And then in addition, the regulation requiring legally verified instrument, okay, like yeah, in Malaysia, like our smartphone must be verified by the MCMC. Okay, there are bodies. Okay, MCMC, they must have certification. Okay, it basically Siren run the process lah. The process they will check for example, the EMI, the electromagnetic interference level. Okay, even our other equipment. So before it can be used, it must have the certified certification. Okay, if you look under or anywhere under your laptop, for example, there will be certification. If no, but of course, um, if you go to the night market, okay, there will be the people selling goods that are not certified. Okay, like for example, battery. Okay, battery, they are not certified. Okay, of course they are there. Okay, in regulation, it shouldn't be trade or shouldn't be there. Okay, but during the export import, it's impossible to screen uh, all the goods. Okay, so they come in box or they come in pallet. Some of it they may contain the goods or things that they are not certified properly, like battery. So in that case, if you use it on but if you use the risk, you have to bear it yourself. Okay, but let's say you use a certified battery, like the common brand uh, we have in our market lah. So we know that okay, like you go anywhere, you have the battery, okay, battery, the common battery, okay, they are certified. Okay, uh, so if you use it, if there is any accident, for example, it broken, cause your equipment, okay, damage to your equipment when you use the battery, okay, then you have the right to claim, okay, for damage. Of course, they must go through a process lah. Then we will investigation and so on. But usually we don't bother to go. I accept the damage is very the damage is very high or very big. But other than that, other than claim, uh, we at least we know that when the item or the goods are certified, we know that they have gone through a standard. Okay, the standard in terms of the process, their process, the manufacturing process, okay, their equipment, okay, their staff, their procedures have gone through a standard process which is certified. Okay, and then they okay. Okay, so these are the services provided by the National Institute under the National Machine. So they are SIRIM. Okay, for example, SIRIM. Okay, SIRIM, you know, they excessively very active, not only provide standard. Okay, in the industry, they also provide the testing. Okay, and also they certified other lab to perform the test. Okay, like in other like food standard, like even like honey, they also have a serum involved in producing the standard. Of course, serum have to work together with the main player of the engineering aspect. Like many of the UTM academicians, they are expert in their field. Like for example, in mechanical, they are an expert in aviation test. So they work together. They come out with the standard of aviation testing. For example, a specific scope on the propeller, for example. Okay. So they work together with the main player or the experts. Okay, they basically just have the uh, what do they have is definitely the authority. Okay, the authority to publish or to come out with the standard. Okay, provided this authority. Okay, the power is provided by the act or the law. Okay. So they provide multiple services as can be seen from the slides. Okay. So the traceability is okay for to support the law in Malaysia, of course, they and then also for the safety. Okay, and also to make sure the market, the market is the follow the standard lah. We don't want anything in the market does not fulfill or will jeopardize the safety of the user. Okay. Accredited lab is basically the third party lab. Okay, it can be other establishment. Okay, okay, any um, okay, like this accreditation is like can cover many aspects of the industry, like food, okay, retail, okay. So the accreditation will follow a certain standard lah. Okay, for example, IEC, IEC 17025. Okay, requirement for the computers for testing and calibration lab. For example, lah, in UTM or SKE, School of Electrical Engineering, uh, there is a lab. Okay, there is lab called Institute of High Voltage, Institute of Voltan and Arus Tinggi. Okay, Arus Tinggi. So, or IWAT. Okay, IWAT. Uh, so there is a big building behind, I think, P06. Behind P06. Behind P06, there is a big building, a square box. So this institute is basically doing the high voltage and current testing. Okay. So they follow this standard ISO or IEC 17025. Okay. So so they are basically accredited to run the test. So what does the test involve? Okay, basically, for example, a company that manufacture transformers. Okay, they want to know the performance. Okay, whether the transformer can withstand, okay, can deliver certain level of high voltages. They can send to EWAT, and then EWAT have the certification to run the process. Also, they can do the they also can come to the company and run the process needed. Okay, they have the equipment. Okay, they are accredited laboratory. Okay, so of course, they have at least in start with the uh, qualified people. Okay, start with the qualified people. Like IWAT, there are professors and lecturers and engineers who are qualified in the field, and then they will start from there. So they will form the group, and then go through the process of registration, and then of course they have to set up the facility and so on. Okay. So there are many other example of accredited lab in UTM. The designated lab in NMI, there are also, okay, and then there are many lab that is developed or set up, okay, in Malaysia or international, to perform the meteorological plan or action. Okay, like for example, how to measure the performance of road, okay, or and so on. Okay, with that being said, let's see some exercise. Okay, let's see some exercise on our topics. Okay. These are the question from the previous test. Okay, previous test. For example, explain the importance of traceability in metrology, especially in the field of manufacturing. In manufacturing, Mm, what is the importance? Okay, what are the importance? So the marks, okay, tell 2 marks. So you can expect to give at least two. Okay, two importance or two benefit, okay, to of traceability in meteorology. Okay, if you recall what I have explained at least, okay, to make sure the standard or the safety, okay, we can say the accuracy, okay. Uh, then what is calibration? You have to give the definition of calibration. Okay? You give the definition of calibration, and then the reason why is calibration important to an instrument. It may seem repeating the same question above, but we'll see the answer later. Okay. And then there's a question on dimension. Okay, dimension here. The question energy on capacitor depend on the value of the charge and the value of capacitance according to, okay, Q. Where U is the energy and Q is the charge value and C is the capacitance value. The dimension of the charge, capacitance, and energy based on the ESU system are based on Q. Okay, mean here the dimension of the charge is given, okay, Q, and the dimension of uh, capacitance is given here, okay, C equivalent to epsilon L, and also here the dimension of the energy is already given. But if x and y are indexes of the dimension, you have to find the index value. Okay, what is the index value of x and what is the index value of y? Now we look at the answer of Q say 7 and 8 first. So these are the miss the the question 6. Okay. So the question 6 is basically three subfield of metrology. Okay. The subfield of metrology. Applied metrology concerns the application of measurement to manufacturing, suitability of measurement, instrument calibration. I think this is like stated in your slide. Okay, you can study and you can ask me the what you don't understand about the concern of each subfield. Basically, you have to know, okay, the concern of each subfield. Okay, question 7. Explain the importance of traceability in terms of manufacturing. Okay, so as I stated, okay, the keyword you have to accuracy. Okay, tool as a mutual recognition among manufacturer, supplier, and customer. Okay, this is one example of answer. Okay, you can give any, okay. It all depends on the answer whether it is the answer whether it is related to the question. Okay, so this is one accuracy. Okay, and then recognized by the party involved. Okay, like we as an user we recognize the accuracy level. We say how do you make, okay, okay, how do you make the food, for example. Okay, okay, then they show their okay, let's say, or you just directly go to the, let's say, um, uh, you want to see the bread factory, you go to the bread factory, okay, okay, and then you look at the bread factory. So if the policy, okay, customer can come, you look, and then you, okay, so people are wearing the proper hairnet, okay, proper face mask and so on. So and then you know that, okay, the process or the okay, and then the measurement, okay, the or everything, and then they clean, okay. Okay, so the thing, the issue will come when there are problems. For example, okay, like if you have car, okay, the your power window is always broken, There is a problem with the with some parts. Okay, for example, the motor and so on. And then we as a user, we can complain. We complain, and then we ask for, at least at our level, we ask for warranty. Okay, compensation. Okay, if you are not satisfied, we can okay, say that they are fraud, for example, because they are selling cheap, or they claim they are falsifying their claim. Where they say okay, this is new uh, parts, okay, but actually they use recycled parts. Okay. What is calibration? Okay, I think this is what you can find from what I have explained, or from the slides. Okay, why is determine determine the performance characteristic, okay, or instrument or reference material, and the process. Okay, you can explain, okay, by direct comparison against measurement standard or certified measurement. Okay, uh, so basically, calibration comes with the documentation. Okay, at least documentation in form of sticker. Okay, and then in the sticker stated the date, it stated the series number, stated the name of the person or who conducted the calibration, and then stated the result, and also state the due date, when is the next calibration process. Okay. The two reasons of for having an instrument calibrated: to ensure reading are consistent, okay, with other measurement, especially other measurement, especially coming from the standard. Okay, especially coming from the standards, and also to determine the accuracy of the instrument reading. Okay, you want to know the error. Okay. Okay, now we come to the question about, uh, regarding the measurement. Sorry, regarding the dimension analysis. But I think I'm going to take a 5 minute break. So 5 minute breaks. So you guys also can. Okay, let's resume the lesson. So in this process, we have dimension here on the left hand side, which is the energy. Then we have on the right hand side the dimension Q and C, which are the and which are the charge and capacitance respectively. So the thing is that we want to know the value of x and y. Okay, so on the right hand side, so, so we have u 1/2 q to the power of x. So these are the relationship of the formula. And c to the power of y. Okay. So we need to find the value of x and y by matching the value of the index on the left hand side and right hand side. Okay. So on the left hand side we have m hang on, m basically here the dimension m to the power of 1, l to the power of 2 times t to the power of negative 2. Then here we have a constant. Okay, so constant, so we can just omit or take that out. We don't have to write. Okay, and then we have q to the power of x multiply with c to the power of y. Right. Okay, so we have written that in the dimension form. Next, we have to this is q m to the power of half l to the power of 3 over 2 t to the power of negative 1 epsilon to the power of negative of x. Okay, multiply with c is epsilon l. Okay, so next we have to match everything on the left hand side so and right hand side. So here we have variables. Here we have is dimension unit m, l, t, and epsilon involved in the whole equation. So we have to match here. So m to the power of 1 multiply with l to the power of 2 multiply with t to the power of negative 2 multiply with epsilon to the power of 0. Okay. So epsilon to the power of 0 equivalent to 1. Okay. Right. So on the right hand side. Okay. So M, yeah, M. So in this case is 1 over x. Okay. So here multiply with the index at the outside bracket. Okay. L. I you know uh, cut to the process. So here 3 over 2x, and here we have Ly. So we have this operation multiply. So here we have 3 over 2x plus y plus y. Okay. T negative x we multiply with epsilon 1 over 2x plus y. Okay, so now we have matched uh, the dimension unit left side, right side, and right hand side. Then the next we compare each dimension unit. We compare the dimension. Okay, so this on the left hand side is 1, right hand side is 1 over 2x. Okay, so we compare this one with this one, the index. So we get 1. The index is 1, supposed to equivalent to 1 over 2x. Okay, so we can solve that. So x will be equivalent to 2. We get the index value of 2. Okay. How about the y? So y, that's one way. The other way we can get x is from here. Okay. X, negative x, negative 2 equivalent to negative x. So directly you can get that the value of x is equivalent to 2. So that's another way to get the value of x. Okay. Then you want to find the value of y. Okay, you can compare the index value of L on the left hand side with the index value on the right hand side, or the index value of epsilon in the left hand side with the index value on the right hand side. So either one should fulfill the so you should get the answer. So let's say we take the epsilon. So 0 is supposed to be 1 over 2x plus y. Okay, plus y. Then we know that x is equivalent to 2. Okay, we put that in. Okay, insert 2 into this. This is the first equation. This is the second equation. So we get the answer from the first equation into the second answer. Okay, we get that y is equivalent to negative 1. Okay, so finally we can, okay, we get all this, we can really rewrite the answer, the final answer. Okay, you equivalent to half, and the final answer is q to the power of 2 multiply with c to the power of negative 1, or q to the power of 2 over 2c. So that's your final answer. Okay, that's the final answer. Okay. Okay. Okay, let's do 5 minutes again. Okay, I think that's conclude our uh, for chapter 1. Let's resume with the next chapter.